Hello, my name is Gabriel Brown. I'm Principal Analyst with Heavy Reading, and I'm here with Durga Malladi, Senior Vice President of Engineering at Qualcomm. We're here to talk about Gigabit LTE, LTE Advanced Pro, and how that drives the market to 5G. Durga, great to see you. So can you tell us a bit about where we are with LTE Pro and what's happening?
So LTE Advanced Pro consists of several features. They start with enhancements to mobile broadband with taking LTE into unlicensed spectrum, introduction of full dimension MIMO, which sets this trend for massive MIMO that's coming up later on in 5G. Introduction of LTE into new verticals such as machine type communications, and eventually leading into narrowband IoT, eMTC, and then going into device to device communication with cellular V2X. So it's like a large number of features that are a part of what comes from release 13 of LTE onwards. And these features are setting the trend and laying the foundation for what's going to eventually come with 5G NR with release 15.
So it seems like you said, a big range of features. Just to pick a couple, tell us a bit about Gigabit LTE and what's happening there, and then secondarily the expansion into vertical industries.
Right. So Gigabit LTE today, when we actually get to gigabit speeds in LTE, it comes from a combination of three different sets of features. You can either increase the number of carriers or increasing the bandwidth. You can increase the modulation order, 256 QAM, and these days we are talking of 1024 QAM. And we can increase the number of spatial layers. Today we talk of 4 spatial layers and so on, 4x4 MIMO. And the combination of these things actually allow us to get towards gigabit speeds depending upon the exact number of carriers and modulation order that is available in a given region. So let's say that if some operator has got 3 carriers, then using a combination of 256 QAM and 4x4 MIMO, you can get to gigabit speeds. If there are 5 carriers, then one could actually go down a little further in terms of modulation order, or go down to a few more spatial or fewer spatial layers, and then increase the speeds again to gigabit speeds. So it allows us to get to gigabit speeds in multiple ways. And as we are looking at our recent X20 announcement that we made, which is our second generation speed in that modem, that allows us to get to these gigabit speeds. First of all, enhance the gigabit speeds. Now it's 1.2 gigabits per second, but also gives us additional capabilities as a part of that. Speaking of the verticals, when we talk about M2M, release 13 is when we first started talking of eMTC and narrowband IoT. We've gone way beyond standards and trials at this point in time. There are commercial deployments that are coming up globally on both Cat-M and narrowband IoT. And that is setting the trend for massive IoT services that will come at some point in time with 5G as well. So these services, the introduction of LTE into verticals, is A, establishing the foundation for what we can build upon in 5G, and B, it's enabled us to actually talk to all the other players in those ecosystems. A lot of them were not very familiar with the cellular ecosystem before, but today they are far more familiar with it, and therefore they're able to place requirements. I would like to have this feature. This is the way I would like to see networks evolving later on. So it's been a very useful exercise in that sense.
Yeah, I mean, I think that's a view we very much share at Heavy Reading, which is developing these business lines in a vertical industry is kind of critical to success later with 5G.
That's correct.
Tell us a bit about this X20. I mean, there is a kind of school of thought that with 5G on the horizon, the runway for LTE is kind of quickly diminishing.
So on that note, I mean, we see a lot of evolution that's continuing to occur in LTE, and it will play a strong role even as 5G comes along. And I can answer that in multiple ways. So let's start with the fact that when the initial 5G deployments come in, predominantly most of them will be deployed with non-standalone mode. In other words, they will rely upon LTE networks for some services and use 5G networks for other services. And in that sense, if you're a user who's got a 5G device, as you're going in and out of 5G coverage, you would like to have some sort of a uniform quality of service regardless of where you are. You could be used to gigabit speeds on 5G, but the moment you get out of 5G coverage, you still want your gigabit speeds. And we're not just talking 1 gigabit per second. Tomorrow it could be 2, and then even more than that. So in that sense, non-standalone mode deployment of 5G actually places a certain way of looking at how the network would evolve, and therefore there is a role for LTE to continue to evolve even in the mobile broadband dimension. And as we think about some of the techniques that are being used, the full dimension MIMO techniques which are coming up with LTE, and that actually laid the foundation for massive MIMO. That is going to be an integral part of 5G in the mid-band services. And as we go to millimeter wave, we're going to use multi-user MIMO techniques as well. So both sub-6 and millimeter wave bands of 5G will rely upon LTE at some level for this non-standalone mode. Whether it's only for control plane services or whether it's for actual data services, that's up to the operator.
Yeah.
So we see a strong role for LTE as 5G comes into the market.
Okay, that's great to hear. Durga,
All right,
thanks very much.
Thank you.